Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video, we are covering CCNA Semester 2, Routing and Switching Essentials, and this is Chapter 10, DHCP. Chapter 10 is divided in two sections. We have Section 10.1, Dynamic Host Configuration Protocol, v4, and Section 10.2, Dynamic Host Configuration Protocol for version 6. Section 10.1 Dynamic Host Configuration Protocol v4. Upon completion of this section, you should be able to describe the operation of DHCPv4 in a small to medium-sized business network, configure a router as a DHCPv4 server, configure a router as a DHCPv4 client, troubleshoot the DHCP configuration for IPv4 in a switched network. Introduction or introducing DHCPv4. In the beginning, we used to assign IP addresses to clients manually. So we had to go to every client machine and assign IP addresses. This is not scalable, so you have to do it on every machine, visit physically every machine and configure IP address, configure the subnet mask, configure the default gateway, DNS, and so on. So when we added more, as more PCs came on the network, then they came up with a bootp. After bootp, we have DHCP. So there's no any other protocol. DHCP assigns these IP addresses automatically. First, bootp. The bootstrap protocol, bootp, is defined in RFC 951 and is the predecessor of DHCP. Bootp will provide the method for diskless workstation to download IP address configuration. Diskless workstation are workstations or PCs without disk drive. Example, think clients, cash register systems. These machines didn't have a disk drives. They didn't have an operating system. They would usually get the operating system from the mainframe long time ago, and they would get an IP address from bootp. Now the bootp used to have manually, you had to go to that server and manually write down the IP address to the MAC address that you can assign it to. So the clients that they would get that IP address dynamically, but you had to do a lot of work pre-hand manually configuring that database. Both bootp and DHCP, they use a UDP, so it's unreliable protocol, and they are known as the bootp ports. Port 67 and 68. 67 is UDP bootstrap protocol, bootp is a server, and 68 is for the client. So UDP port 68 is destination is for the clients, and 67 the destination is for the server. Then the DHCP emerged as a standard protocol in October 1993. This is defined in RFC 1531, succeeding the bootp protocol. DHCP allows a host to quickly and dynamically obtain configuration parameters from a DHCP server. In an enterprise, DHCP is almost exclusively always configured on a dedicated server. So now the client, you don't have to do like the legwork like before with the bootp, that you have to go to the bootp server and configure that database of all the IP addresses, bind them to all MAC addresses and so on. With the DHCP, everything will be happening in dynamically. So all you have to do is create the pool or scope that's known in other vendors, and then the DHCP is going to assign the IP addresses automatically. The information of configuration parameters that DHCP is going to assign is like we said with the manual. We have an IP address that we have to have it unique in local area network. We have to have a subnet mask that we need to define what network we belong to, and we need to have a default gateway. So if we want to communicate to someone outside our network, then we need to know who we're going to send it to. Then we have a DNS server. We need to assign a DNS server because as human beings, we don't remember IP addresses. We do remember names, and we need a server who's going to resolve these names to an IP address. And then we have to assign ourselves a domain name. Where do we belong? So there's three ways that you can assign IP address through DHCP. The first method is called static manual allocation. The administrator statically assign a pre-allocated IP address to the client, and DHCP only communicates the IP address to the device. Pretty much very similar to what was in the bootp. Then we have a dynamic allocation. DHCP automatically assigns an IP address from a pool of addresses. So here we just create a pool, for example, address from 1 to 100, and the DHCP automatically will choose one and it will assign it to the client. This address that's been assigned to the client it's a leased address, so it's for a limited period of time, and it's this limited time we configure in the server, or you can release the IP address from the client. So when the client doesn't need that IP address, then it can release ipconfig/release. You end the lease early. Or we can have automatic static allocation. The DHCP automatically assigns a static IP address permanently to a device, selecting it from a pool of available addresses. There is no lease, and the address is permanently assigned to a device. So this one, dynamic allocation, we would use it for all the client machines, like laptops, desktops, pretty much, and so on. Static manual allocation, you will have to define, you have to bind the IP address to MAC address. This we will put it to some devices who cannot get an IP address automatically. Like, we can't statically assign an IP address to the device. The device wants the IP address dynamically, but we want the same address always to be for that device. For example, some printers, some old printers, you can't assign the IP address statically to the printer, but we do want that printer to have the same IP address always. So we go to the DHCP server and we statically configure that, so we can bind it. Or we can let if we don't care about the IP address, which IP address is going to be chosen, then we can let it automatic static allocation. The DHCP is going to pick one and it's going to permanently assign that IP address to the printer or to any device you need. This is DHCPv4 Operation. So we have a server on the left and the client on the right, and it's going to start, all this communication is going to start from the client. The client is going to start sending a broadcast message, and this broadcast message is known as DHCP discover message. It's asking, is there a DHCP server who's going to give me an IP address there? So I would like to request an IP address. The client doesn't know if there is a DHCP server. We just send it a broadcast message, which means everybody's going to get it. And it's down to the DHCP server. It's going to reply. It's going to say, yep, I've got an IP address. This is a unicast. I'm a DHCP server 1 here, and I can give you an IP address. This is known as the DHCP offer message. And then if the client is happy with that IP address, it's going to request. So it's going to send another broadcast packet saying, yep, I like that IP address. Can I please have it? And then in turn, the DHCP server is going to send a unicast packet back to them and saying, yep, your acceptance is acknowledged and the IP address is yours, including other information like IP address, subnet mask, gateways, and the lease time. When the lease time expires, or when it reaches 50% of the time it's been leased, so for example 3 days here, when it reaches to 1.5 days, then the client is going to send another request saying, yep, can I extend my lease for another 3 days please? And if the server is there, it's going to reply saying, yep, acknowledged, you have another 3 days. If the server is not there, so if the server, for example, is not answering, then the client is going to wait for another 50% of the lease to expire, try again, then wait another 50% to the lease to expire, try again. If it reaches 0, then the client is going to go through this process again. Sends a broadcast, DHCP discover, trying to find out the DHCP server. So this is known as, I'm just going to mark it here. So what we have is DHCP discover, so that D, discover. We have a DHCP offer over there. Request, DHCP request, yeah, just the R. And we have acknowledgement. So this step is known as DORA in the field. So if I write it like this, sorry, like this, DORA. This is DORA process, where the client sends a discover message, the server sends an offer, the client sends a request, and the server sends acknowledgement. Now DORA, I don't know how you're gonna remember, but for me, when I was studying, my children, they watched Dora Explorer, and it's a good cartoon, and that's how I remembered it. Anyway, so if we look at the Wireshark, for example, the first message is going to come from the client. So this is a Wireshark capture. So we can see that client is using the source 0000, and the destination is a broadcast 255.255.255, and we can see there's a DHCP discover message. So we're discovering this DHCP. So I can see underneath these are Ethernet 2 or layer 2 frame information here. We can see that it's a broadcast message. We can see that it's sending our MAC address. So the source MAC address, the source is already knows MAC address, but the MAC address of the destination I don't know. So that's a broadcast message. Then the source IP address is all zeros because the client doesn't have an IP address, and destination at layer 3 address is all 255s, 255, 255, 255, 255. And then you can see the source port is boot P C for the client is port 68, and destination port is boot P S for the server, port 67. Then the server is going to do is ARP. So it's going to try and find out, okay, well, I'm gonna lease you 192.168.2.5, but before I lease that, let me do an ARP resolution, try and find out maybe somebody else is using that. So the second message that is coming here is ARP, right? So the server with this MAC address is sending a broadcast message, is sending an ARP. It's saying, okay, does anyone has 192.168.2.5? Because that's what I'm going to offer to the client, right? It doesn't say that, but it just says, okay, does anyone is using this address? If nobody's using that address, then the server is going to offer that address to the client. So you can see the server is actually sending it as a unicast. It's already sending it to that address, even though it's just offering it. So we have here DHCP offer message. And you can see the server's port 67 and the client's port 68. Now, if the client is happy, the client is still not using that address, because even though if it's just been offered, can't use it, it's going to request. So again, the client will go to nothing. I don't have any IP address, and it goes back to broadcast, saying, okay, would you can I request that address, please? It's using the broadcast MAC address as well as his own physical MAC address. So it's using a broadcast MAC address, but the IP address of layer 3 information is all 0, and destination is a broadcast. At this time, the PC is saying, yep, I like that IP address, please. And the last message that's going to come from the server is acknowledgement. Yep, you can have that IP address, and the information here we can see, again, very similar to what we saw early on. But now, okay, the source address is from the DHCP server, and destination address is 2.5, which is the address now of the client who did this broadcast. Again, just not to forget, we have a D for discovery, O for offer, then we have R for request, and A for acknowledgement. A router or DHCP roles. Router could be act as a DHCP server. So the router or Cisco router could be leasing these IP addresses. So it's acting as a DHCP server. Router could be acting as a client. So it could be a client to another DHCP server. For example, what we learn here in our network, our router is going to be a server. It's going to assign IP addresses. Imagine, like, think of it at home. Yeah, you have a router who goes to the internet, and that router leases IP addresses to your client machines at home, like laptop, TV, PlayStation, or whatever you have there. Now the router at home, it's a client to a DHCP server to the IP your ISP. So again, the role of the router could be as a DHCP server, or it could be as a DHCP client, or DHCP router could be acting as a DHCP relay agent. So for example, if this DHCP server, this is our DHCP server here. If I mark it here, that's our DHCP server. Now this client sends a broadcast. When it sends a broadcast, hits this router, the router is going to, by default, is going to block all the broadcasts. It's going to stop them here. But if the router is a DHCP relay agent, it will take this broadcast and it will unicast them to the server. This server will unicast it back to the client, to the router, and the router will send a unicast to the client. You can see that's a relay agent. To configure a DHCP server, the DHCP server is enabled by default on the newer iOSs. If you want to disable that service, you go No Service DHCP. If you need to enable or re-enable that service, is Service DHCP Global. This is a global configuration command. So you type service, like other service command, service password -encryption, or any service command. This is just a service. Service DHCP Global. So to configure DHCP, first thing is we need to define excluded address ranges. Which addresses we do not want to give out. So for example, if you have addresses range from 1 to 100, that's your pool. Maybe address 50 is already taken. You don't want that to be given out. So the first thing you need to do is you need to exclude the addresses they don't want to list out. Then you will create a DHCP address pool. For example, you create that pool from 1 to 100. You have to give a name, and then you go inside DHCP configuration mode. And third, you configure the specifics of the pool. So enter the DHCP configuration mode and configure the specifics like the network and the default gateway, the DNS, and so on. We'll see it very, very soon. You do not have to apply the pool to an interface. An interface will use the pool which it belongs to. So step 1, exclude addresses from the pool. So define a range of addresses that DHCP is not to allocate. These are usually static addresses reserved for the router interfaces, switch management IP addresses, servers, and local network printers. So the global configuration mode, the command is IP DHCP excluded -addresses, and then if it's a range, you can put from the low address to the high address. So for example, if there's a range from 50 to 60, you put .50 here and the .60 on this side. IP DHCP excluded, this is the one of the commands. So we excluding from 1 to 9. So the first address that will be leased out is 10. Or you don't have to do it like this. If it's not on the range, you can do it one by one. The DHCP excluded addresses 192.168.10 to 254. You could have done like 1, enter, then do it again, .2, enter, .3. But if it's in the range, it's easy if you just do it the whole thing. Put the low address first and put the high address after. Or you can put one by one. Then we have to create a DHCP pool using the IP DHCP pool command. This will enter you into DHCP configuration mode. So the pool name, anything that you want. Usually written in the capital letters, no spaces, just you can separate it with hyphens. So IP DHCP pool, give a name, line, -pool, -1. And then we are entering DHCP configuration mode. From DHCP configuration mode, then we can configure a DHCP specifics. So step 3, enter the DHCP configuration mode and configure the DHCP specifics. We have some tasks that you have to complete them, and some of them tasks are optional. So required task is to define the address pool. What is the network that you're going to be assigning to the IPs, to the clients, or leasing them to the clients? So the command is network, and then network number, and then the mask, or you can put the prefix length. The next is to assign a default gateway. So for example, default -router and the address of the router. Those are the two required commands. Well, one more required command would be, for example, the DNS server. Without that, the clients really can't go to the internet. So to define the DNS server, DNS-server and then the address of the server, I would actually put this in here on this task rather than optional. Anyway, this will work. These things that will work. But even without the default gateway, just need to define the pool. It will still work. Define the domain name. So domain -name and then the domain name. Define the duration of the DHCP lease. So lease, you can lease it in days, hours, minutes, or infinite, which is forever. Define an option code, instance number. You can put, for example, here option 150 and then give an IP address. Like here we can configure option 150 is used for IP phones to get the configuration from the TFTP server. This you can define it with option, and then all of these commands you can define it with the option. You can have the option, whatever option they are using. Use a question mark. That's what I would recommend you. So this is how the whole configuration. So a Cisco router running a Cisco IOS software can be configured to act as a DHCP version 4 server. To set up a DHCP server, we said we exclude the addresses from the pool. That's the first thing. Then we set up the DHCP pool name. Then define the range of addresses and subnet mask. Use the default -router command for the default gateway. Optional parameters that can be included in the pool are like DNS server, as we said, and domain name. You can see that's our full configuration for this DHCP instance. To verify a DHCP server, we do show IP DHCP server statistics, and this will display the count for server statistics and messages sent and received for iOS based DHCP server. Show IP DHCP binding. This will display the DHCP binding information for IP addresses assignment and subnet allocation. Show IP DHCP conflict. This will display address conflicts found by Cisco IOS DHCP server when addresses are offered to the client. And show IP DHCP pool, and then the name displays the subnet pool allocated and the current utilization level for the pool, or all the pools if the name argument is not used. Now we will see a DHCP configuration example. What we'll do, we'll configure the DHCP for this LAN, so for PC1 connected to switch 1. So the first thing is to exclude the first 9 addresses and the last host address on this network. So you can see 192.168.10.0, that's our network. So we have to go to the global configuration mode, and the command is IP DHCP excluded -addresses 192.168.10.1 from 10.1 to 192.168.10.9. So that will take away first 9 addresses, and as well as the last address, so 192.168.10.254. We need to create a pool, and this pool is called LAN-pool-10. So in there, IP DHCP pool, LAN-pool-10. Assign the network address. So you can see the network is 192.168.10/24. So 192.168.10.0/24. So in the DHCP configuration mode, we type network 192.168.10.0 space 255.255.255.0, that's /24, and then identify the default router. You can see that's our default router's IP address, 192.168.10.1. So default -router, that's a gateway, 192.168.10.1. Configure the domain name to be span.com, so domain name span.com, and that's all configuration. One configuration here that I would write down will be the DNS server. You have to define where is your DNS. Your DNS doesn't have to be local. Your DNS server could be somewhere else as well, on another network. So before PC1 boots, show IP DHCP binding. You can see that there's nothing here. We don't have an IP address. We don't have a MAC address. We don't have a lease expiration date or type. So show IP DHCP server statistics. We can see the address pools that we have 1. We haven't received any requests or any discover, any decline, release, information, anything, messages we didn't receive, or we haven't sent any messages either. A binding is a collection of configuration parameters, including at least an IP address associated with or bounded to a DHCP client. Binding are managed by DHCP server. After the PC1 boots, show IP DHCP binding, we can see that we have given the first available address to the client, which is 192.168.10.10, the client's MAC address, then the lease expiration, when the lease is going to run out, and how we are leasing them is automatic. We can see that some of the statistics. So we have automatic binding, we have 1. We have a DHCP discover 6. We have received DHCP discover message broadcast 6. Request, we have said 6. We have received 1. And the offer is 1, and further down is acknowledgement 1. DHCP problems, for example, say in our network, we don't have a DHCP server. No, in our LAN, local area network, we don't have a DHCP server. The DHCP server is located on this second LAN here. So when this PC1 sends a broadcast message towards everybody on the local area network, now there's a problem because our DHCP server is on a different network. So the router will not forward any broadcast message. If router did forward broadcast message, then the DHCP server will get that broadcast, but the router doesn't. So router blocks any broadcast message to send them to another network. So what we can do here, if we run ipconfig, release and renew it's never going to work because the broadcasts are never going to reach the server, the DHCP server. So we can use a helper address. Remote clients may require DHCP services and send broadcasts to locate these servers. Routers by default will not forward client broadcasts beyond their subnet. Solution would be to, well, you can place a DHCP server on all subnets. Everywhere there's one DHCP server. Not very good and not very scalable. Or we can use Cisco IOS helper address feature, which is great because what the router is going to do when it receives or it sees a DHCP broadcast message, it's going to take that message and it's going to unicast to send a unicast to the DHCP server. So DHCP server doesn't have to be on the local area network. The IP helper address enables a router to forward a UDP broadcast to specific unicast IP address. This is configured using the IP helper address interface configuration command. Command relays UDP broadcast request. Configured on the interface receiving the broadcast. This is a big statement here. Configuring on the interface receiving the broadcast. There's no point for you to configure the helper address on the, because it's an interface in configuration. There's no point to you to configure it somewhere else. You have to configure it on these interfaces. They're gonna hear those broadcasts. If I go back to this slide here, so because it's an interface configuration mode, so you can't really configure here, because in here you're gonna hear maybe the broadcast messages, but these PCs broadcast message, you will never receive it on this interface. You will only hear it here. So it's important the helper address is configured wherever you hear the broadcast messages from the client. So you would configure it on FA00. Okay, let's move on forward to the configuration. So you go to the interface configuration mode, IP helper -address, and then the address of the where is the DHCP. Enables forwarding and specify destination address for main UDP broadcast packets. Change destination address from broadcast to unicast or direct broadcast address. Now by default, if you enable the helper address, is not only going to enable to send DHCP messages, but it's going to send other messages as well. If you do want to stop to send these other protocols, then you have to stop with IP forward - protocol. So the configuration, for example, the DHCP relay, you have to go to interface FA00, as you can see here, and then say IP helper address and the IP address of the DHCP server. ipconfig release, when you do ipconfig renew, you should get a new IP address from the DHCP server. By default, the IP helper address command forwards the following 8 UDP services: time, TACAX, port 37 time, port 49 TACAX, port 53 DNS, 67 for DHCP, 68 for DHCP server, 69 TFTP, 137 NetBIOS name services, and 138 NetBIOS datagram services. Maybe we only want to send these two. We have 67 and 68. So why we are forwarding other protocols as well? If we don't want to forward the other protocols as well, you have to use the IP forward protocol global configuration mode command to restrict or forward any UDP ports in addition to the default 8. So once you do IP helper address, you can say IP forward protocol UDP 123, no IP forward protocol, and you can choose which one you don't want to forward. We can configure our router as a DHCP version 4 client, and all we have to do is we go to the interface. That's our small office, a home router connected to ISP. We go to that interface and we say IP address DHCP and no shutdown. And if we look, we will get an IP address from the DHCP server. So show IP interface G01, we can see the address has been determined by DHCP. Troubleshooting tasks. We have few tasks we have to go through if we have a DHCP problem. First, we need to check if there's any conflicts and we resolve these conflicts. Verify physical connectivity. Test with static IPv4 address. This is a great method if you see if there's a problem with the DHCP server for some client. You just go to that client machine and assign manual IP address and see if it works. If there's a problem, maybe with a physical layer 1 maybe problem. Verify the switch port configuration. Maybe the port that the PC is connected to is in wrong VLAN. and obviously it's not going to get the correct DHCP information, and test from the same subnet or VLAN. So you go to another machine and test it from there. To verify DHCPv4 relay and DHCPv4 services, show running config, and maybe we just want to see the section interface gigabit Ethernet 00, and we can see that we have a helper address there. Show running config, include no service to see if the service is enabled. So no service DHCP. We don't have anything returned, so that means the DHCP is running. Debugging the DHCP version 4. Now this is a great command. You don't have to use it just for DHCP. You can pretty much use it for anything. You know, for DNS, you just change the port numbers here. Okay, what happens? You create an access list first. Extended ACL. The permits, for example, we permit in UDP. It's coming from any port, and it's going to from any source, sorry, and it's going to any destination. So any source with any port to any destination equal to the port 67. So we create another access list 100, permit UDP, any source with any port going to any destination as long as they are using equal to port 68. So that's access list we have created. So we're saying as long as they are using port 67 as a destination and port 68 as a destination, that's our access list. And then we can say debug IP packet 100. So if we just say debug IP packet, we're going to see a lot of debugs, a lot of debug messages. I mean, it's very hard to actually pinpoint what we're looking at, what we need to find. But here, debug IP packet 100, we are like defining what access list, depending on what access we have created, we will see those debug messages. So we will see only debug messages from whatever access list 100 permits us. Debug IP DHCP server events is going to show us if there is a DHCP discover messages, offers, and so on. Thank you very much for watching this section 10.1 Dynamic Host Configuration Protocol v4. Please have a look at my other videos and don't forget to subscribe. This has been Asir Krasniqi, and next video 10.2 Dynamic Host Configuration Protocol for IPv6.